Okay, so we're going to do a quick starter on logs just to refresh our memories. So here it says they want you to find, giving your answer to 3 significant figures where appropriate, the value of x for which 3 to the power of x is equal to 5. Okay, so here I've taken ln of both sides, and then using the laws of logarithms, I'm going to take the x over. So then I've got x equals ln 3, ln 5, so x is equal to ln 5 over ln 3. I'm going to plug this into my calculator. Okay, I've got 1.46. Okay, so it says 3 significant figures, so I need to be careful. For part B, again, I need to use the laws of logarithms, which means that when I'm subtracting here and they've got the same base, I can therefore write it as log base 2, and in brackets, 2x plus 1 over x is all equal to 2. This means 2 to the power of 2 is equal to 2x plus 1 over x, which then means you've got 4x is equal to 2x plus 1. So you have then 2x equals 1, therefore x equals a half. So that's 0.5. Okay. Right, so we are revising pulleys. So let's have a look at this question. It always helps to highlight key bits of information that we have, what we're given. So it says 2 particles, A and B, have masses 5m and km. Okay, so this is important, 5m, km, where k is less than 5. The particles are connected by a light, inextensible string, which passes over a smooth, fixed pulley. So if it's smooth, it means that the tension is going to be the same throughout. It then says the system is held at rest with the string taut, so this therefore implies that U is equal to 0. Okay. The hanging parts of the string vertical with A and B at the same height, so they're the same distance away from the horizontal plane. And the system is released from rest, and after release, A descends with an acceleration. So we know here that it's going downwards, A is going downwards with an acceleration of 1/4 g. Okay, so that then implies that B is moving upwards. I'm just going to add on my forces here. I'm just going to put in 5 mg and kmg, and I also have my tension, which is going to be the same throughout, so I'll call them both T. Show that the tension in the string as A descends is 15/4 mg. Okay, so part A, 15/4 mg. Okay, so if it's moving downwards, so let's have a look at the forces that are happening over here with A. So for particle A, what we have is you've got 5 mg minus the tension is equal to ma, so mass times, so using F equals ma. Okay, so your mass is 5m and your acceleration, we're told, was 1/4 g. Now it's just a case of rearranging and making T the subject. Which leaves you with 15/4 mg. So as required. Just to say, if you weren't able to do part A and prove that 15/4 mg is the tension, then you could still go on to part B. And part B, all you would need to do is use the tension that they gave you. Okay. Now for part B, you are asked to work out the value of K. Okay. So you want to work out the value of K. So for this, we need to look at what's happening to our particle B. Okay, so for B, it's moving upwards, which then means that the tension is greater. So it's T minus kmg. The mass is km, and the acceleration is 1/4 g. Okay, Now here we need to substitute in our value for t, which we have been told already. So this is why it doesn't matter if you got part A incorrect, you could still move on to part B, which is quite good. So you substitute in your 15 over 4 mg minus k mg is equal to k and then you've got a quarter g. I'm going to take the minus kmg over to the other side, and then I'm going to factorize it. So I've got 15 over 4 mg is equal to, I mean, I could just divide out by mg already, but I'll do that in a minute. So take the k over and factorize. So you've got mg plus m, and then you've got a quarter g. Okay. And then divide by mg plus a quarter mg. Okay, so I'm just going to write that over here. I know it's looking a little bit messy right now, but it will simplify beautifully in a moment. I'm just going to write mg over 4. Okay, now once you've simplified, so let's get rid of this mg, it's really annoying me. So mg, that cancels down to 1. Okay, and then we multiply everything out by 4. So if we do that and multiply everything out by 4, we've got 15 at the top, and then we have 5 at the bottom. And so k is equal to 3, and they did say that k is less than 5, so I know that this is correct. I've done the right thing. Okay, so that's the part B. Okay. For part C, the question is, state how you have used the information that the pulley is smooth. Well, we've used the information that the pulley is smooth because we've assumed that the tension throughout is the same. Is the same throughout the string. Tension throughout is the same. Yeah. Okay. And then the next part is, after descending 1.2 seconds, the particle A reaches the plane. It is immediately brought to rest by the impact with the plane. The initial distance between B and the pulley is such that in the subsequent motion, B does not reach the pulley. There's a lot of information there. So let's break this down. So it's moving, it says descending, so particle A is moving down for 1.2 seconds. So that then implies that particle A is moving up for 1.2 seconds, naturally. It is immediately brought to rest by the impact of the plane. So that means it reaches the plane. Okay. The initial distance between B and the pulley is such that in the subsequent motion B does not reach the pulley. So I'm going to quickly draw a diagram again. Okay. Okay, so what I've done is I've drawn a little diagram for you guys. Just one moment, I will quickly just draw that again. Hold on. Okay. Right, sorted. So what we've got here is, I've drawn the diagram. Apologies, my drawing isn't great, but hopefully you've got the gist of what I'm trying to say. So the string is no longer taut, okay, it's slack. When A hits the ground, it's no longer taut, okay? So I'm going to work out first the distance of A above the ground, okay? So that's my first part to answering this question, the distance of A above the ground. I want to know what is the actual distance it needs to travel, because I need to know that to actually work out the greatest height that is reached by B. So let's work out the distance. So the distance of A above the ground, okay? And to do that, I'm going to use S equals UT plus a half AT squared. So to do that, okay? I'm going to call this the first distance S1, all right? Now S1 is then equal to, remember the initial velocity is 0, so this cancels out. And so I'm just left with half, and the acceleration was a quarter g, as we were told in the beginning, and t is 1.2 seconds. So it'll be 1.2 seconds and it's squared. Okay, this gives me 0.18 g. Now I'm not going to round anything because I just want to, I'll round it at the end. I just want to make sure that my answers are exact for now. The next thing is I want to work out what's the speed on reaching the ground. What's the speed of A on reaching the ground? Because if I know the speed at which A hits the ground, this is going to be exactly the same speed at which B will be moving, okay? At the instant that A hits the ground, okay? This is important. So I'm going to use V squared equals U squared plus 2AS. Again, see that. Now, my velocity is going to be the value which we have worked out. Okay, apologies. I'm going to use V equals U plus AT, actually. This is much easier. So V equals U is 0, and that's just your acceleration was a quarter g. So just put a quarter g, and then your time is 1.2. This gives you 0.3 g. Okay, so we have S1, which is the distance traveled by A, so S1. Basically, it's the height at which both of those particles are above the plane. So S1 is 0.18 g. I worked out the velocity of A at which it hits the ground, which is 0.3 g. I'm going to rub out the rest of my work here so that I have space now to calculate what's happening with B. Okay, so particle B. So I'm just going to rub that out. Okay. Yep. Okay, so now for B, for particle B, let's have a look and see what's going on here. Again, I'm going to use V squared equals U squared plus 2AS. Okay. The velocity is 0.3 g for B as it's approaching the pulley, because that's going to be the same as the speed with which A hits the ground. Okay. And this is going to be, well, U is 0 because it's from rest. And then you have 2 times A. So when A hits the ground, when particle A hits the ground, the only force that's working on B, pushing it down, is gravity. So it will be gravity, just G. Okay. And so I'm going to work out what's the small distance it travels. So that's, I'm going to call it S2, because remember, you want to work out the greatest height reached by B. Okay. So rearrange this and make S2 the subject. Okay. So that is going to be, I rearrange this, I'm going to have to write this out. Okay. So rearrange it, make S2 the subject, and this is what I get. So the greatest height reached by B is therefore going to be, so I'm going to call that big S, okay? Now you've got to remember the initial diagram showed 2 particles hanging down each side of the string, and they were the same distance above the plane. So what that means is that, and I should have probably drawn this out so that you could see the string a little bit longer. Yeah, I think that's better. So here you've got particle A, particle B. So the distance that A travels, B will also travel up the same distance, okay? Right? But it will also travel up a little bit longer because of the impact with which A hits the ground. It means that B is forced to move up a little bit more, just from the impact with which A hits the ground. You also need to remember that it's already above the ground, okay? and that's going to be S1. It's already above the ground. So it's going to move S1, it's S1 above the ground, and then it's going to travel another S1 because of A. And then there's this little bit here that it travels, which is S2, okay? So the greatest height with which it reaches is going to be S is equal to 2 lots of S1, which we've just said, plus S2. And so the total is going to be about 3.969, which is approximately 4 meters, okay? All right, I hope this helps. Please do let me know if you have any questions.